handle tie is not required in this case. However, if the handle tie kit is installed, then it must be used. See National Electrical Code Section 240.15b. National Electrical Code Section 210.4 states that a multiwire branch circuit is permitted to be supplied by a single-pole circuit breaker enclosed in a panel board. National Electrical Code Section 240.15b requires that the circuit breaker supplying a multiwire branch circuit be equipped with a handle tie. However, since the circuit described is not a multiwire branch circuit, this requirement does not apply. National Electrical Code Section 408.16 states that supplementary overcurrent protection devices, such as the two single-pole 15 amps breakers, can be installed in a panel board. Since these breakers are not required to have a handle tie by National Electrical Code Section 240.15b and do not fall under any other code section requiring a handle tie, then no handle tie is required. Let's break down these code sections and what they mean for electrical installations. Firstly, National Electrical Code Section 240.15b focuses on the overcurrent protection requirements, specifically dealing with series ratings and the use of circuit breakers or fuses in series. This section allows for the use of overcurrent devices in series under specific conditions, ensuring that the downstream device is properly protected by the upstream device. The key here is that the combination must be tested and marked for series operation, and the interrupting rating of the downstream device must be sufficient for the available fault current at its terminals. The handle tie issue comes into play when considering multi-wire branch circuits. Secondly, National Electrical Code Section 210.4 addresses multi-wire branch circuits, which are circuits that consist of two or more ungrounded conductors that have a voltage between them, and a grounded conductor that has equal voltage between it and each ungrounded conductor of the circuit, and which is connected to the neutral or grounded conductor of the system. A common example is a 240/120 volts 3-wire circuit used in residential settings where you have two 120 volts hot legs and a neutral. This section permits these circuits to be supplied by a single overcurrent device, like a two-pole breaker, in a panel board. This ensures that if one leg of the circuit trips, all legs are disconnected simultaneously, enhancing safety. Thirdly, National Electrical Code Section 240.15b is more specific, requiring that if a multi-wire branch circuit is supplied by single-pole breakers, they must be equipped with a handle tie. This is to ensure that all poles of the circuit are disconnected simultaneously by manual operation. This is a critical safety measure to prevent situations where one leg of the circuit remains energized while the other is de-energized, which can be hazardous for anyone working on the circuit. Finally, National Electrical Code Section 408.16 covers supplementary overcurrent protection. This section allows for the installation of supplementary overcurrent protection devices within a panel board. These devices are typically used to protect specific appliances or equipment and are in addition to the branch circuit overcurrent protection. The key point is that these supplementary devices are not required to have handle ties unless specifically mandated by other code sections. In the scenario described, the two single-pole 15 amps breakers are considered supplementary overcurrent protection devices within the two-pole 30 amps 240 volt single-phase breaker enclosure. Because they are not feeding a multi-wire branch circuit, they do not fall under the requirement of National Electrical Code Section 240.15b and do not need a handle tie. Now, let's consider some additional scenarios and factors that might influence the need for handle ties. One scenario is where local amendments to the National Electrical Code may impose stricter requirements. It's always important to check with the local authority having jurisdiction to ensure compliance with all applicable codes and regulations. Another factor is the specific application and the type of equipment being protected. Certain types of equipment may require handle ties for safety or operational reasons, even if not explicitly mandated by the National Electrical Code. In industrial settings, for example, it's common to use handle ties on breakers that supply critical equipment to ensure that the entire circuit is de-energized during maintenance or repairs. Furthermore, consider the potential for future modifications to the electrical system. If there is a possibility that the circuit may be reconfigured as a multi-wire branch circuit in the future, it may be prudent to install a handle tie now to avoid having to make changes later. Remember, the primary purpose of handle ties is to enhance safety by ensuring that all poles of a multi-wire branch circuit are disconnected simultaneously. This prevents the risk of electric shock and makes it safer for electricians and other personnel to work on the circuit. In summary, the decision of whether or not to use handle ties on circuit breakers depends on a variety of factors, including the type of circuit, the applicable code requirements, and the specific application. While handle ties are not always required, they are often a good practice to enhance safety and prevent potential hazards. Always consult with a qualified electrician or electrical engineer to ensure that your electrical system is properly designed and installed. Furthermore, consider the impact on circuit integrity and maintenance procedures. Handle ties offer a distinct advantage during maintenance, allowing for a complete isolation of the circuit with a single action. This reduces the risk of accidental energization while work is being performed. Now let's delve into the nuances of multi-wire branch circuits and why handle ties are so crucial for the safe operation. A multi-wire branch circuit, as defined by the National Electrical Code, shares a common neutral conductor. This means that the neutral conductor carries the unbalanced current from the ungrounded conductors. If one ungrounded conductor is disconnected while the others remain energized, the neutral conductor can become overloaded, leading to a voltage imbalance and potential damage to equipment connected to the circuit. This is where handle ties come into play. By ensuring that all ungrounded conductors are disconnected simultaneously, handle ties prevent the neutral conductor from becoming overloaded and protect the equipment connected to the circuit. In addition to overload protection, handle ties also provide a convenient way to isolate the entire circuit for maintenance purposes. With a single action, all ungrounded conductors are disconnected, minimizing the risk of accidental energization. The National Electrical Code provides specific guidelines for the installation of handle ties. They must be securely attached to the circuit breakers and designed to withstand the forces exerted during normal operation. The handle ties must also be listed for use with the specific type of circuit breakers being used. It's important to note that handle ties are not a substitute for proper wiring practices. The circuit must be properly designed and installed in accordance with the National Electrical Code to ensure its safe operation. This includes using the correct wire size, properly terminating connections, and providing adequate overcurrent protection. In conclusion, handle ties are an essential safety component of multi-wire branch circuits. They prevent neutral conductor overload, protect equipment, and provide a convenient way to isolate the circuit for maintenance. By following the National Electrical Code guidelines and using proper wiring practices, electrical systems can be designed and installed to ensure safety and reliability. Understanding the application of handle ties extends to various electrical systems, each with its own set of considerations. For instance, in residential settings, multi-wire branch circuits are commonly used for kitchen and bathroom circuits, where multiple appliances and devices are powered from a single circuit. In these cases, handle ties are crucial for protecting the shared neutral conductor and preventing voltage imbalances that could damage sensitive electronic equipment. In commercial buildings, multi-wire branch circuits are often used for lighting and receptacle circuits. Handle ties are equally important in these applications, ensuring that all phases of the circuit are disconnected simultaneously during maintenance or repairs. In industrial facilities, multi-wire branch circuits may be used for powering machinery and equipment. Handle ties play a critical role in preventing accidental energization during maintenance procedures, protecting workers from electrical shock hazards. Furthermore, the selection of handle ties should be based on the specific type of circuit breaker being used. Different manufacturers offer handle ties that are specifically designed for their circuit breakers. It's important to choose handle ties that are compatible with the circuit breakers being used to ensure a proper fit and reliable operation. In addition to handle ties, other safety devices can be used to enhance the safety of electrical systems. These include ground fault circuit interrupters, arc fault circuit interrupters, and surge protective devices. Ground fault circuit interrupters protect against electrical shock by detecting ground faults and interrupting the circuit. Arc fault circuit interrupters protect against electrical fires by detecting arc faults and interrupting the circuit. Surge protective devices protect against voltage surges that can damage electronic equipment. By incorporating these safety devices into electrical systems, a higher level of protection can be achieved. In summary, handle ties are an integral part of electrical safety, particularly in multiwire branch circuits. They prevent neutral conductor overload, protect equipment, and provide a convenient way to isolate the circuit for maintenance. By following the National Electrical Code guidelines, selecting the appropriate handle ties, and incorporating other safety devices, electrical systems can be designed and installed to ensure a safe and reliable operation. Now, let's consider the practical aspects of installing handle ties. The installation process is relatively simple, but it's crucial to follow the manufacturer's instructions carefully. Before installing handle ties, ensure that the circuit breakers are de-energized and locked out to prevent accidental energization. The handle ties typically consist of 2 or more interlocking pieces that snap onto the handles of the circuit breakers. The pieces should be securely attached to the handles and aligned properly to ensure that they operate smoothly. After installing the handle ties, test the circuit breakers to verify that they trip simultaneously. If the circuit breakers do not trip simultaneously, the handle ties may not be properly installed, or the circuit breakers may be faulty. In either case, the problem should be addressed before energizing the circuit. In addition to proper installation, regular maintenance is essential to ensure the continued safe operation of handle ties. Periodically inspect the handle ties for signs of wear or damage. If any damage is found, replace the handle ties immediately. Also, ensure that the handle ties are kept clean and free from debris. Dirt and grime can interfere with the operation of the handle ties and reduce their effectiveness. Furthermore, consider the environmental conditions in which the handle ties are installed. In harsh environments such as those with high humidity or corrosive chemicals, the handle ties may be more susceptible to damage. In these cases, it may be necessary to use handle ties that are specifically designed for harsh environments. In conclusion, handle ties are a critical safety component of multi-wire branch circuits. Proper installation and regular maintenance are essential to ensure their continued safe operation. By following the manufacturer's instructions, inspecting the handle ties regularly, and considering the environmental conditions, electrical systems can be designed and installed to ensure safety and reliability. Now, let's consider the implications of not using handle ties when they are required. Failure to use handle ties in multi-wire branch circuits can create a number of safety hazards. One of the most significant hazards is the potential for neutral conductor overload. As mentioned earlier, the neutral conductor in a multi-wire branch circuit carries the unbalanced current from the ungrounded conductors. If one ungrounded conductor is disconnected while the others remain energized, the neutral conductor can become overloaded, leading to a voltage imbalance and potential damage to equipment connected to the circuit. Another hazard is the risk of electrical shock. If one ungrounded conductor is disconnected while the others remain energized, a person working on the circuit may come into contact with an energized conductor, resulting in an electrical shock. The severity of the shock can range from a mild tingle to a fatal electrocution. In addition to safety hazards, failure to use handle ties can also result in code violations. The National Electrical Code specifically requires the use of handle ties in multi-wire branch circuits. Failure to comply with this requirement can result in fines and other penalties. Furthermore, failure to use handle ties can void the warranty on electrical equipment. Many manufacturers require that their equipment be installed in accordance with the National Electrical Code. Failure to comply with this requirement can void the warranty, leaving the owner responsible for any repairs or replacements. In summary, failure to use handle ties when they are required can create a number of safety hazards, result in code violations, and void the warranty on electrical equipment. It is essential to follow the National Electrical Code guidelines and use handle ties in all multi-wire branch circuits to ensure safety and reliability. Now let's delve into the specific requirements for handle ties as outlined in the National Electrical Code. The National Electrical Code provides detailed guidelines for the installation of handle ties, including the types of handle ties that are permitted, the methods of installation, and the testing requirements. According to the National Electrical Code, handle ties must be listed for use with the specific type of circuit breakers being used. This means that the handle ties must be tested and certified by a recognized testing laboratory, such as Underwriters Laboratories, to ensure that they meet the applicable safety standards. The National Electrical Code also specifies the methods of installation for handle ties. The handle ties must be securely attached to the handles of the circuit breakers and aligned properly to ensure that they operate smoothly. The handle ties must also be designed to withstand the forces exerted during normal operation. In addition to these requirements, the National Electrical Code also requires that handle ties be tested after installation. The circuit breakers must be tested to verify that they trip simultaneously. If the circuit breakers do not trip simultaneously, the handle ties may not be properly installed, or the circuit breakers may be faulty. In either case, the problem should be addressed before energizing the circuit. Furthermore, the National Electrical Code requires that handle ties be inspected regularly. The handle ties should be inspected for signs of wear or damage. If any damage is found, the handle ties should be replaced immediately. The National Electrical Code also requires that handle ties be kept clean and free from debris. Dirt and grime can interfere with the operation of the handle ties and reduce their effectiveness. In summary, the National Electrical Code provides detailed guidelines for the installation, testing, and maintenance of handle ties. By following these guidelines, electrical systems can be designed and installed to ensure safety and reliability.